So today we are going to start looking at the role of each of these coefficients in a parabola. So the coefficients that I'm talking about are A, B, and C. So today we're focusing on A. All right, so here's how we're going to look at this. Okay. See, technology. Okay, so here we go. We have, can you all see that okay? You have a parabola. The parabola right now, I don't know if I can see this on here, but it goes through 0, 0, and you can see up at the top here, y equals 1x squared plus 0x plus 0. Okay, so what we're going to do is we're going to change the value that's in front of the x squared. That's the a value. So let's say this. Let's say that instead of 1x squared, we have 2x squared. Raise your hand if you have a guess as to what you think is going to, something's going to happen to the parabola. So does anyone have a guess as to what will happen with the parabola? If I change it from y equals 1x squared, so change this from 1x squared to 2x squared. What do we think? Stacy? What do you mean get bigger? Like wider? Okay. Okay, does anybody have any other guesses? 2x squared instead of 1x squared. So what the first guess was that it gets wider. Chaz? It'll get skinnier. Okay, any other guesses? Shifting? No, we don't think shifting is... All right, so let's see. Okay, so let's replace that with a 2. Oh. Okay, so it got skinnier. So if I keep increasing it, you can see how it gets skinnier and skinnier and skinnier the bigger that A gets. Oh, it actually makes noise. You guys hear that? The clicking? Okay, now, what happens, what do we think happens if it goes to a negative number? It goes down, okay, it goes downward. Oh, okay, look at that. So it's saying cannot be 0. Why? So if I try to go to 0, it tells me I can't. Why can't A be 0? We talked about that yesterday, but why? What's the reason? So we're talking about quadratic functions, remember. What do we think? No guesses? Okay, so a quadratic function is a function that has an x squared in it. If a is 0, what is 0 times x squared? 0. And so then it's no longer a quadratic function. Okay, so let's make it -1 instead. Okay, so it flips downward if it's a negative. Okay, so keep that, and then again, if we make it even bigger negative, it becomes more narrow negative. All right, so here, what we're going to do is use this to write a little description of the role of A. So, can somebody tell me one thing they noticed there in that little lovely demonstration? Marcy.
That the smaller the number is, the wider the parabola becomes.
Good. The smaller A is, the wider the parabola is. The wider or more open it is. Okay, what else? Anything else that you all noticed? Okay, right, so A cannot be 0, because if A equaled 0, then that would mean we would not have a quadratic function. What else? What happened when we made it a negative? It turned upside down. Good. So, if A is positive, that means the parabola opens which way? Up or down? Up. Okay, so it's an actual U. But if A is negative, then it opens down. Okay, so it opens like that. Okay, now let's just really quickly one more time. If it opens upward, does that mean that the U, or the parabola, has a low point on the graph or a high point? A low point or a minimum. Okay, so then the vertex is a minimum. Right? So the vertex is right here, and that is the lowest point that the graph is going to be. Now, if it opens downward, is the vertex the highest point or the lowest point? The highest, or a maximum. Good. So, check out how easy your homework is going to be tonight. Everybody have that?
Yes.
Okay. So there's a lot of writing here, but here's what we can do. Let's just go through them really fast, and then I'll pause it and let you all copy it down. So no one write anything down yet, okay? I know that this is going to kill some of you, but that's okay. Because I want you to see how easy it is.
There's another one here.
Okay, here we go. Without graphing, classify these functions as opening up or down. Okay, y equals negative 6x squared. Who can tell me whether that opens up or down? Jade.
Down.
Why?
Because it's negative.
Down because it's negative. Everybody give it up for Jade. Okay, next. Y equals 4x squared. Akashni. Why is it up? Because it's positive. Everybody give it up for Akashni. Next one. Taylor. Down because? Good. Everybody give it up for Taylor. And how about the last two? The last two. Ashley G.
Up because it's positive.
Up because they're up or P in my. Okay, because they're both positive. Excellent. All right, everybody give it up for Ashley. Okay, now the next piece of this, again, I'll pause it in just a second, is that using these same graphs, we want to classify them as least steep. Least steep means like that versus most steep or skinny. Okay? So, looking at all of these, now it does not specify whether it's positive or negative. It doesn't matter whether it's positive or negative. It's just which one has the smallest absolute value and which one has the largest absolute value and what that means for the graph. Okay, so having said that, which one is the least steep, meaning the widest? Here, Marcy.
The one on top. I mean,
This one?
Oh, you meant out of the numbers.
Yeah.
The least steep is the biggest number. So I can't really see. I don't wear glasses. The -6 one.
Okay, you're right, that's the biggest absolute value. That's actually the most steep. So the bigger the absolute value, the skinnier it is. The smaller the absolute value, the wider it is. So now having said that, Kendra? The -1/8 goes here. So we're basically looking for the smallest absolute value and then up to the biggest absolute value. Okay, we've gotten, so far we've done that one and we've done that one. So we still have to place y equals 4x squared, 1/3 x squared, and 1.5 x squared. So which one comes directly after -1/8? Rachel, and then I'll get Haley next.
1/3.
1/3, good. Everybody give it up for Rachel. Okay, and then Haley, which one comes after that?
1 1/2.
Good, 1 1/2. Everybody give it up for Haley. And then again, we have y equals 4x squared after that. So does everybody see the pattern there?
Yeah.
Yes? Oops, sorry. All right, let me pause it so you all can copy it down. Sketch the graph. More sketching. Y equals 1/3 x squared and y equals 3x squared on the same graph. Underhill's gone again.
Yeah.
That's why it's so quiet. Okay. Then, write the equation of the axis of symmetry and the coordinates of the vertex. Would you all like to know the trick now to graphing these so you don't have to make tables? Okay. Okay. The first thing that we're going to do here is we're going to find the vertex. Okay. Actually, let's separate these. Y equals 1/3 x squared, and the other one, y equals 3x squared. So in order to, let's just go back for a second, to graph a line or to draw a line from geometry, you have to have at least how many points? 2. Okay, with a parabola, you have to have a bare minimum of 3. You have a curve. Okay, so one of the points is the vertex, and then you need 2 points on either side of the vertex so that you have where that curve is supposed to go. So we're going to start with that, and then we'll go from there. All right, so would you agree that in y equals 1/3 x squared, we don't have a 0x, or we don't have an x term, and we don't have at last term, right? Okay. So remember that the coefficient in front of x squared is a, the coefficient in front of the x is b, and the last one is c. We're going to use those to help us find the vertex. So remember, a vertex is a point. It has an x-coordinate and a y-coordinate. So we're going to start with the x-coordinate. Okay, to find the x-coordinate, we do -b/2a. And I will actually show you where that comes from when we focus on the coefficient b over the next couple days. Okay, so you can see where this relationship comes from, so sit tight. Take my word for it for now. Okay, So we get negative 0 over 2 times 1/3. So what is 0 divided by anything? 0. Okay, so that's the x-coordinate. Now, if we know the x-coordinate is 0, how do we think for this function we could find the y-coordinate to go along with it? Plug it in, right. So to get the y-coordinate, 1/3 x squared is our function. We're going to take the x that we just found and plug it in. So 1/3 times 0 squared is 0. All right, so our vertex is at 0, 0. Okay, so we just found one of the things that we were supposed to be finding. Okay, let's start our graph down at the bottom, and then we'll go back and deal with the y equals 3x squared thing. Okay. Okay, so here's how it works. We can make this kind of big. Let's see, we'll do every 2 is 1. So everybody draw a graph on your paper. Okay, 1, 2, 3, 4, 6. Okay, so here we go. We're going to put the vertex first. Whoop! Yes. So the vertex for y equals 1/3 x squared is at 0, 0. That's our first point. Okay, now here's what we do next. Yeah. Yes. That was funny. Akashi, do you have a question? That's good. Okay, so here we go. All right, from the vertex, here's what we do. We look at what our a term is. That's always the one in front of x squared. And that's how many we go up from the vertex. So we go up 1/3. 1/3 is right in here somewhere. Okay, so we obviously don't have a point directly on top of that vertex. We actually go out 1 in either direction. Okay, so you always go from the vertex. Let's actually write this out. From the vertex, you go up or down a, and out 1 in each direction. And that's how you get your other 2 points. Okay, so again, if we're looking at this as an example, we have our vertex here. We go up 1/3, because a is 1/3, and then out 1 unit in each direction. Okay, and then connect those. We'll talk about ways to find more points as we progress with our discussion of parabolas, but for now, that's good. Questions? So it might seem like it takes long, but it's actually a lot quicker than making a table. Yeah?
What does it say in green on the side?
It says from the vertex, you go up or down whatever a is, which in this case is 1/3, and out 1 in each direction. Other questions? Okay, so now let's do the other one. This is our last example, by the way. Let's do the other one. So for the vertex xy, can somebody tell me how I would start setting up my vertex for y equals 3x squared? And again, imagine we plus 0, x plus 0. We don't have that information. So, Marcy?
You do negative b over 2a, which would be negative 0 over 3, 0.
Good. So, perfect. Okay, so the x-coordinate is 0, and if you go back, we can do this in our heads. If you go back and plug it into here, you get what? 0. So this also has a vertex at 0, 0. So let's go down here and let's do it in a different color so that we don't get confused. Let's do y equals 3x squared in red. So we start at 0, 0 again. So it has the same vertex, but now, since our a is 3, how many are we going and in what direction from the vertex? 3 up or down? How do we tell if it's up or down?
Positive.
Positive, good. So we go up 1, 2, 3, and then what? Out 1 in each direction. Okay, so you can see, now if you were to do a table, these values would match what we're doing. So you can see that the y equals 3x squared is a lot steeper than the 1/3. Okay, how are we doing on questions? We can just answer the last ones out loud. It says find the equation of the axis of symmetry for both of them. The axis of symmetry goes along here. It's x equals 0 or the y-axis. And then we already said what the vertex was. Is the vertex of each of these a maximum point or a minimum? Minimum. And that's it.
Wait, line of symmetry is 0.
X equals 0 for the axis of symmetry. Yeah. Okay, other questions? Okay, you guys can start on your homework now.